Hi, my name's John. Welcome to another Wednesday catch up. This video is going to carry on from last Wednesday's catch up, all about lining the lathe up, lining the lathe tailstock up and the headstock. I'm going to show you another method of doing it, which is probably the most accurate way you can do things. I had a good weekend at the NEC Classic Car Show. I spent most of my time on the RTEC stand and on the Extreme Plasma stand. I didn't get to see a great lot of the show, but what I did see was fantastic. There was quite a few viewers come up and said hello and shook me hand. It was really great to meet you. It's nice to put faces to the names because all these lads often comment on my videos. One thing I like to do is give a massive shout out to a lad called John Graves. John's been in hospital recently. He's back home now, so hopefully John, you're on the mend. If you send me your address, that's my email up there. I'll try and find something to send in the post to try and help you on your way. Anyway, all the best, mate. I hope you get well soon. When I was at the NEC show on the Extreme Plasma stand, I had to go with a machine called an arc droid. It's basically a robot computer control arm with a plasma torch on the end. It's very compact and cuts things out. As you well know, I have got a CNC plasma table. So Rob is going to send us one of these up to do a review on, as well as a brand new RTEC plasma cutter that goes with it. I'm looking forward to it. It's different to the plasma table. It's got different uses. I'm sure you'll find it interesting. I'm really looking forward to getting stuck into it. The best way to ensure that the tailstock of the lathe is in line with the headstock of the lathe is to put a piece of bar between centres and turn it for its full length and measure the diameter at each end. We're not really concerned about the centre part, it's each end we're concerned about. So it is a simple tool you can make without wasting a long piece of bar to check for lathe line up. I've got a piece of 12mm stud here. I'm going to drill each centre and then make a couple of washers to go on to it, held on by nuts. Then we're going to machine one end, machine the other end, measure them and make sure the lathe is in fact absolutely spot on. I'm just going to use plastic for the parts I'm going to machine down. It's all it needs to be. I'll drill a 12mm hole in there and part a couple of discs off. I'm not quite sure what's happened at the end of that, but it looks like it's had a bit of a miserable existence. I use a tool I normally use for plastic. There's a much better result when these little button tools. Ta-da! That bit of board can save a lot of heartache if you're damaging your lathe bed by dropping chucks onto it, hitting it with hacksaws and that sort of thing. You would normally use what's called a catch plate on here. I haven't got one. I did have one, but I machined it down to take a chuck. Use it as a back plate, so we can use this face plate just the same. Exactly the same job. So into there goes the adapter. I think I've got a shorter taper than that. Right, that's the one that we used last week. We actually machined on the job. Still running nice and true. That's it assembled. The two plastic bits jammed between nuts. A centre hole in each end that goes into that centre. That's the dead centre, and the other end is called a live centre. That spins like that. It's irrelevant what happens here. It can be bent, it makes a difference. We're interested in that there and that there. We need a method to drive it. That's what they call a drive dog. We need a bolt or something in there. So when it spins round, it catches that, and that's what drives it. This is the most accurate way of turning a lathe between centres, because you can take it out, turn it around, you can put it back in, and it will run dead true. Right, so we'll find a bolt to drive that with, and then we'll have a go and show how far away this lathe actually is. Right, so that will come round, and that's what drives it. You've got to be fully aware of what you're doing here. That's big bits spinning around. What that wants to hurt you. If you get caught in there, it really is going to spoil your day. So you want no flappy shirt sleeves, no ties, nothing silly like that, no bits of rag lying around the lathe. Always stand this side of it, be careful, respect it. Right, I'm going to take a line cut off each one just to make them round. Doesn't matter what size they are, we're just going for a comparison end to end. And so that's cleaned up nicely. We'll do the other one on exactly the same setting. I'm just going to check for clearance here between everything. There is plenty of clearance. We're going along to there, and I have got clearance, albeit just. Right, we'll just do this again because I lost my setting. Just a fanny's hair, just a little whisper, that's all you need. Right, case now, I'm measuring these, they should be both exactly the same if the lathe is set up dead true. Right, we'll measure this end first. We'll get 44.8. This end we've got 44.75, so it is the same. 44.8. Micrometer time. These micrometers, it's actually the thimble that's got the ratchet in, not the end bit. Right, so we're talking it's exactly the same size. Right, measure this one. That's showing 25 on the thimble. We'll go to the other one and give the camera running so you can see I'm not going to cheat. Right, we've got 2.5, so it's the same size at both ends. I'm not even going to possibly out by 0.01, which is nothing. It spoiled the video because it's right, but I'm not going to adjust my lathe now, that's for sure. Once again, just time to say thanks for watching, thanks for subscribing. If you haven't subscribed, please do, it is important. I've nearly have got the magical 100,000. Anyway, thanks for watching.